Today we're going to compare what we know about ratio tables to what we can learn about double number line diagrams. Here's a scenario we can use. The amount of sugary beverages that Americans consume is a leading health concern. For a given brand of cola, let's say a 12-ounce serving of cola, it contains about 40 grams of sugar. Using that information, let's complete this ratio table with equivalent ratios. To find out how much sugar a smaller amount of cola might have, I could take the values that I already have and divide them by the same number. I could use 2 or I could use 4, and in this case I'm going to divide by 4. So 12 divided by 4 will give me something, and 40 divided by 4 will give me something. And I'm left with, for every 3 ounces of cola, there are 10 grams of sugar. Now going the opposite way, if I wanted to find out how much sugar is in a larger amount of cola, I could multiply both of the values by whatever number I would like. I'm going to make it simple on myself, and I'm just going to double that amount. So I'm going to multiply both by 2. And now I can see that for 24 ounces of cola, I would have 80 grams of sugar. So here's my completed table. Yours may look different depending on what values you use to fill it in. But no matter what your values are, our ratios should be the same because these are all equivalent. Now we have a 1 liter bottle of cola. It has approximately 34 fluid ounces of soda in it. The question is, how many grams of sugar would be in that 1 liter bottle of cola? Well, using what we know here, do you see anywhere that shows us how much sugar a 34-ounce drink would have? No, the highest we have is 18 ounces. So we're going to need to extend the table. I'm making 3 more slots. We might need more or less, but we can experiment. I can notice at the table that we have already doubled the 6 to 20 to get 12 to 40, and we've tripled it to get 18 to 60. So to get the next set of values, I'm just going to multiply both by 4. And 6 times 4 is 24, and 20 times 4 is 80. And we have a new set of values now. We can see that 24 ounces of cola would have 80 grams of sugar. But we are not yet at our 34 ounces. So let's multiply our 6 ounces of cola and our 20 grams of sugar times 5 this time. In doing this, I know I'm going to have an equivalent set of values because this will be the same ratio. I'm just multiplying it by 5 instead of 4 or 3 or 2. So 6 times 5 is 30, and 20 times 5 is 100. And so I have a set of values that says 30 ounces of cola would have 100 grams of sugar. This still isn't reaching our 34 ounces of cola, so we need to do this one more time. Okay, what is 6 ounces of cola and 20 grams of sugar needing to be multiplied now to get our next set of values? Of course, we'll need to multiply by 6 because last time we multiplied by 5 and by 4. So what is 6 times 6 and what is 20 times 6? All right, we have a new set of values that says 36 ounces of cola will give us 120 grams of sugar. Now, the question was, how many grams of sugar are in 34 ounces of cola? Notice that 34 is not exactly on this table. We can estimate, we can make a guess and say that 34 ounces, because it's between the 30 and the 36, would be somewhere between 100 and 120 grams of sugar. But what if we wanted to be exact? So instead of using a table, I'm going to move to a number line. And on this number line, I'm going to illustrate the ounces of cola. And you'll see here that these are the exact same values of ounces of cola we had in the table, 0, 6, 12, 18, 24, 30, and 36. But where we need to find out grams of sugar, and so we are making a double number line, which means that one side of the number line is going to show us one thing, and the other will be something else. For instance, on the top of this number line, again, we have ounces, and on the bottom is going to be grams. And we need to match up the grams with the corresponding values from our table. So 0 will go to 0, of course. 20 grams of sugar will go with the 6 ounces like we had in our table, and so on and so forth. Okay, so what I'm going to do is I'm going to focus in on this area where the 34 ounces would be. It's between the 30 and 36. So what we'll need to do is to make some new hatch marks that will give us all the values between 30 and 36. And if I zoom in, you guys can see them right there, 31, 32, 33, 34, and 35. Of course, those would be the numbers between 30 and 36. And so our 34 ounces would be right there. Now, we still don't know how many grams of sugar, but let's work with what we have. We know that the grams of sugar is going to be right there as well. It's just that we don't know exactly what that number is yet. But But we do know that the value from 100 on the left to 120 on the right is a certain exact amount. What I mean to say is we know what this gap is from 100 to 120. We knew on the top in terms of ounces of the drink that it was 30 to 36, and we could figure out, 31, 32. But we can do the same with the grams underneath, 100 to 120. How big is that gap? Of course, to go from 100 to 120 would be a 20 value gap. So all of those markers that I've already made correspond with something that would equal 20 when all of them are added together. So I know that all of my new markings put together will equal 20 grams. Here's where it gets a little tricky. What we can do at this point is also see that from 100 to 120, or 30 to 36 ounces, is one whole. And all of those new hatch points we made are part of a whole. And if we want to go to 34, that would be the fourth one in, and it takes 6 of those hatches to make a whole. So that 34 ounces is actually 4/6 of the way across this hole. I can mark the rest of them 1/6, 2/6, and so on. That is helpful because if I know that that gap in grams is 20 grams, and if I also know that 4/6 is how far I want to go, then I need to find out what 4/6 of 20 is. And that will tell me how many grams I moved from 100 to that 4/6 mark. And remembering how to deal with fractions, if I want to know what 4/6 of 20 is, I just multiply. And multiplying fractions means I can simply multiply the numerator times the numerator and the denominator by the denominator, and I'll end up with 80/6. Now, I can already see, because both of those sets of numbers are even, that I can simplify this fraction even more. I'm going to divide both by, I'll start with 2. So 80 divided by 2 would be 40, 6 divided by 2 would be 3, and now I have 40 thirds, and yeah, I can't simplify that anymore. So 40 thirds, you know what, that doesn't sound very helpful at all. What I want to do is, I want to know how many holes are in 40 thirds, so I'm going to divide the top by 3 to find out how many sets of 3 are inside of 40. And I find out that, there are 13 sets of 3 inside of 40 with 1 unit left over. So my actual fraction is 13 whole and 1/3 left. So what does that tell me? What is this point 13 and 1/3 actually saying? Well, remember, it isn't 13 because where are we on the number line? We're past 100. So it's actually 113 1/3. So I have 113 1/3. After all of this work, we can now say that this 113 1/3 is grams of sugar that a 1-liter bottle of cola would have. Whew! Good job. Keeping with our sugary drinks theme, a school cafeteria has a restriction on the amount of sugary drinks that they are offering to students. The restriction states that drinks may not have more than 25 grams of sugar. Based on this restriction, what is the largest size cola in ounces that the cafeteria can offer to students? Okay, what is it that we know? Well, the restriction states that drinks can't have more than 25 grams of sugar, and the question is, what's the largest size soda that can be offered without going over that 25 grams of sugar? Let's create a table to see if we can figure this out. Okay, the great thing is we don't have to recreate the wheel. We already have a table that tells us how many grams of sugar per cola ounces. So we can use this to solve this problem. What I have done is, because we know that we can only have 25 grams of sugar, I am zooming in, and my focus on this double number line is going to be between the 20 and the 40 grams of sugar. And the question is, what would be the ounces of soda that we could have if it was right at 25 grams of sugar? Once again, because I know that from one hatch mark to another I can call one whole step, I can break that step into parts. And for this giant step, I can see that there are 4 parts. If I go by fives, right? 20, 25, 30, 35, 40, there are 4 jumps I would make. So each one is worth 1 of those 4 jumps. And since I want to go to the first jump, the 25 mark, that would be 1 jump of the 4. So I have 1/4. What I also know is that in terms of ounces of cola, from the 6 to the 12 is a total of 6 ounces of cola. This will help me because all I need to do is find out what 1/4 of 6 is, and then I will know how far in ounces I have jumped from 6 to 25 grams of sugar. And finding 1/4 of 6 is as simple as multiplying the numerator and numerator, and that would be 6, and the denominator and denominator, that'd be 4. So I have 6/4, which I automatically know I can simplify, so I will. So what I end up with is 3/2. And I know that 3/2 is equivalent to 1.5, and I'm going to use that instead because it makes it easier for me to add those whole numbers. And now, to find out exactly how many ounces that hatch mark is, where the 25 grams of sugar is, I know that it's 1.5 steps from 6. So what is 6 and 1.5 steps? 7.5. And this answers the question, how much cola can a cafeteria offer without going past the 25 grams of sugar mark? Well, the most soda that they can offer is 7.5 ounces. Today we really looked at one thing, and that is going from ratio tables to double number lines. The usefulness of using a double number line as opposed to a table is that we can see the values directly across from each other, and that we know that each hatch mark is telling us another set of values that are equivalent to the rest because of the ratio. Also, we know that each jump is one whole, and so we could do things like finding specific amounts that are in between the jumps by cutting those whole jumps into parts using fractions.